Hello guys, in today's grade 12 mathematics trigonometry exam clinic, we're looking at a question paper from the Department of Basic Education's Mathematics Paper 2 of the November 2025 examinations. So question 5, let's see. It says, given that tan 50 degrees equals k, express each of the following in terms of k. 5.1.1 cos 40 degrees. So 5.1.1, you should realize they are talking cos 40 degrees, but you are given tan 50 equals k. So these are ratios. So we will use right-angled triangle for these trig ratios. Now, something you should know about tangent. Something you should know about tangent is that it is opposite over adjacent. It seems the opposite side here is k units, and we should therefore say the adjacent is 1 unit. So this is the adjacent, it is 1 unit. With that being said, we will then need to find the hypotenuse. Using Pythagoras theorem, we will say r squared equals x squared plus y squared, right? Plus y squared. This is Pythagoras theorem, right? Then we do not know what r squared or r is. We know x is 1, y is k, right? So here we have r squared equals 1 plus k squared. Therefore, r will be square root of 1 plus k squared. Okay, r will be equal to the square root of 1 plus k squared, right? Moving on. When we move on now, you should be careful. The question said cos 40 degrees, not cos 50 degrees. What you know, sum of angles of a triangle is 180. And besides that, for a right angle triangle, the other two sides must be a sum of 90 degrees, right? So if this one is 50, so this one must be 90 minus 50, so it will be 40 degrees. And by the way, we just found that this side is 1 plus k squared, right? We just found that this guy is 1 plus k squared, square root of 1 plus k squared. Now, with this triangle complete like this, we can proceed and say, what is cos 40 degrees? Cosine is adjacent over hypotenuse. A side that is adjacent to 40 degrees is this one that is k units long. So we will say our answer is k over the square root of 1 plus k squared, right? You good? Perfect. Moving on. When we move on now, we are looking at 5.1.2. We need to express 2 sine 25 degrees times cos 25 degrees all over negative 2 plus 4 sine squared 25 degrees. For the numerator, a part of me says, I see something like 2 sine x cos x. And you and I, we know 2 sine x cos x is the same as sine 2x. And with what I'm seeing x equals 25 degrees. Then what would be 2x? This therefore would mean 2x is 2 times 25, which is 50 degrees. So this will be sine 50 degrees. Okay, let's go. Now we will say this equals sine 50 degrees all over. In the denominator, I see a common factor, and that common factor, it seems like it will be negative 2. I will take it out, negative 2. Now, negative 2 divided by negative 2 is positive 1. Negative 4 sine squared 25 divided by negative 2 will be negative 2 sine square 25 degrees. Hold on, I'm seeing something that I know even here. I'm seeing 1 minus I'm seeing 1 minus 2 sine square x, and this I know for a fact it is cos 2x. Just like we said there, 2x will be 50 degrees. All right, so this will be cos 50 degrees. Right, let's go now. Proceeding, we will say negative sine 50 degrees over 2 cos 50 degrees. Right? Now, sine over cosine, we know that this is an identity that we call cosine, tangent. So sine over cosine is tan. Now this is negative tan 50 degrees over 2. But hold on. The question said you must express each in terms of k. We know tan 50 degrees is equal to k. Therefore, we can say our answer is negative half times k, or negative k over 2. Right? We can say that. Okay. All right. Good. Moving on. We go to 5.1.3. Let's see what it says. 5.1.3 says sine 10 degrees. Sine 10 degrees, when you look at our right angle triangle here, we can use perhaps 60 degrees minus 50. That can work. We can also use 50 degrees minus 40 degrees. And the reason is it's a compound angle. So I want to say to you, this we can say is the same as sine 50 degrees minus 40 degrees. All right. Remember, I said you can also say 60 degrees minus 50 degrees. And 60 degrees will be a special angle. All right. Good. Perfect. So with this, I will say you remember the compound angle formula of sine was sine A minus B will be equal to, let me just go there, will be equal to sine A cos B minus sine B cos A. You guys remember this? So even if you don't remember this, the information will be provided for in the data sheet. Okay? This formula is in the data sheet. So what do? We will say this becomes sine 50 degrees cos 40 degrees minus sine 40 degrees then cos 50 degrees. Looking at our diagram, we're going to look for sine 50. Sine 50 is opposite, which is k over square root of 1 plus k squared. Let's go. Right? So it's k over square root of 1 plus k squared. And then cos 40, it seems it'll be the same, but I will confirm. Okay? I will confirm. Let's go back to confirm. Cos 40 cosine is, or we did find cos 40. All right? So we're good. It's k over square root of 1 plus 40. All right? All right. Now minus sine 40, it seems it'll be 1 over square root of 1 plus k squared. And then cos 50 will also be 1 over 1 plus square root of 1 over square root of 1 plus k squared. Let me go check sine 40 and cos 50. Indeed, sine 40 is 1 over square root of 1 plus k. Cos 50 as well is 1 over square root of 1 plus k. So we are good. Okay, with what I'm seeing here, k plus k times k is k squared. Square root of 1 plus k squared multiplied by square root of 1 plus k squared is the same as writing it as 1 plus k squared. The same here, 1 times 1 is 1. The very same thing, it's still 1 plus k squared. Now, when denominators are the same, we add numerators. This becomes k squared minus 1 over 1 plus k squared. You can leave it here. There's nothing that you can do because you cannot factorize the denominator further. So leave it here. It's okay. All right. Cool. Let's move on now. 5.2. Let's try to up the pace now. We want to finish this in whatever mark allocation. At least we should finish this question in 17 minutes. Simplify the expression above fully to a single trigonometric ratio. Cool. Sine 540 degrees plus x cos 90 degrees plus x all over sine negative x. Okay. Now, whenever you see an angle greater than 540, always subtract 360 from it. So 540 minus 360 will be 180 degrees. Okay, it will be 180 degrees. By the way, this is 5.2.1. So this will be sine 540 minus 360. You said it's 180. We can reduce it to this. Okay. Cos in the 90 plus quadrant is negative. And because of the 90, cosine will change and become sine. Okay. And become sine. Okay. Perfect. Sine negative angle will always become negative sine that angle. Okay. Good. I repeat, sine of a negative angle will always become a negative sine of that angle. Okay. All right. Now proceeding, sine in the 180 minus. If you like, by the way, you can just say negative sine cancels with negative sine. You can say you're left with sine 180 degrees plus x, it's okay. And then say sine in the 180 plus, how is it? It's negative. So this then becomes negative sine x. Okay? This becomes negative sine x. All right, that was 5.2.1. 5.2.2 says, hence determine the values of x in the interval x is greater than 0 degrees included. Oh, sorry, x is an element of 0 degrees included to 360 degrees included, for which the square root of what we just expressed will be real. So you do not have to worry. This guy here, sine 540 degrees plus x times cos 90 degrees plus x all over sine negative x, right? The square root of it is the same as the square root of negative sine x. All right. So they say, when will this be real? So this guy here will be real. So this is basically taking you to grade 10 and 11. This guy will be real if, if negative sine x equals 0 or negative sine x is, okay, maybe I shouldn't be doing it like this. It's better this way. Is greater or equal to 0. Okay, this is true when this guy is greater or equal to 0. So try to draw your negative sine x. It'll be like this, okay? It'll be like this. Now, what you want the value of negative sine x where it is 0. Where is it 0? Here it is 0. Let me use a different color. It is 0 here, it is 0 here, and it is also 0 here, right? And then where is it positive? It's positive here, right? Do you see this? It's positive here. So what do you do then? You then say, oh, this must be, x must be equal to 0. That's a fact, right? When x is equal to 0, honestly speaking, this is it. When x equals 0, right? Alright, this is when x equals 0. Do you guys agree with me? It's when x equals 0. Or if you like, you can say also this is when x is greater than, what is this? If this is 0, this is 90, this is 27, 180. What a jump. This is 180 degrees, 270 degrees, and then this is 360 degrees. Right? So this is when x is greater than 180, not greater or equal to 180 degrees, but less or equal to 360 degrees. Okay, this could be where this equation is satisfied. Okay, so this is it. All right, perfect. Moving on. You see, now we were able to finish this in approximately 17 minutes. That says we are on the right track. Okay, perfect. Let's go to question 6. Question 6. Let's see. It says, prove that tan open bracket 180 degrees minus x close multiplied by cos open bracket 1 minus cos square x close plus cos square x equals open bracket sin x minus cos x close multiplied by 1 plus sin x cos x close all over negative sin x, and then all over negative cos x. You need to look at this and say, which one do you think it's easy to manipulate? It is not easy to manipulate the right hand side to give you the left hand side. So rather, we will take the left hand side. So the left hand side says tan 180 degrees minus x close multiplied by 1 open bracket 1 minus cos square x close plus cos square x. Right, so we begin this by saying tan in the 180 minus quadrant, is it positive or negative? Tan in the 180 minus quadrant is negative, so this will be negative tan x close. 1 minus cos square x, let's look at the identities we know. Sin square x plus cos square x equals 1. Hold on, I'm seeing 1 minus cos square. I think it's trying to say to us cos square x equals 1 minus, sin square x equals 1 minus cos square x. So we can change this term and call it sin square x. All right. All right, moving on. This we're saying it's becoming sin square x close plus cos square x. Moving on. Tangent, we know its identity sine over cosine. So it'll become negative sine x over cos x multiplied by sine square x plus cos square x. Negative sine x times sine square x will become negative sine cubed x all over cos x plus cos square x. Moving on. When we simplify this bracket, we will be having negative sine cube x plus cos cube x all over cos x. All right. So this says to us we have a difference of 2 cubes. All right. We have a difference of 2 cubes. So having a difference of 2 cubes, let's play with it. We can say difference of 2 cubes. We can say a cubed minus b cubed is the same as saying open bracket a minus b close open b a squared plus ab plus b squared. Okay, plus b squared. Do you guys see this? When you have a difference of 2 cubes like this is what you can say. All right, so this therefore says to us, remember, it's like our a is the cos x, right? Now, proceeding, we'll say this is the same as saying, let's say cos x minus sine x close, then it becomes cos square x plus cos x sine x plus sine square x. Ooh, plus sine square x. Okay, plus sine square x all over, right? All over cos x. Now, as we proceed, I want to show you here, we have cos square x plus sine square x. And I see that somehow we need a plot, a y. We know sine square x plus cos square x, like I showed you here, is equal to 1, isn't it? It is equal to 1. All right, let's go. Now, we can say this will become cos x minus sine x, but also, you also need to be careful. This guy here, we have sine x minus cos x, but here we have cos x minus sine x. So how about we take negative as a common factor? Let me show you. Negative, we take it as a common factor. Then if you take negative as a common factor, we can say we have negative cos x plus sine x, right? And then what did I say to you just now? Cos square x plus sine x equals 1. So this becomes 1 plus cos x sine x all over cos x. Now let's rearrange this in a way that you know. The way that you're seeing it on your question paper, you can just say put the sine x first. It is the same thing, guys. Sine x minus cos x close open 1 plus sine x cos x all over negative cos x. Agree with me that this is the same as the right hand side. You were able to prove this identity. Okay? You were able to prove this identity. All right. Moving on. 6.2. Let's see now. I will explain 6.2. It says to us, it is given that sine square x, cos square x, and half sine 2x are the first 3 terms of an arithmetic sequence. The constant difference of the arithmetic sequence is not 0. Determine the general solution for x. Okay, let's see. We have sine square x, cos square x, and half sine 2x. Perhaps let me simplify this. We have sine square x, cos square x, and then you know this one here, I will show you. I can write it as sine x cos x. I'm going to show you why I'm saying this. So this, we know that it is half, right? We said it is half sine 2x, but we know sine 2x is the same as saying 2 sine x cos x. As you can see, half times 2 becomes 1, hence I wrote sine x cos x. Okay, perfect. Now, they said this is arithmetic. This is just something that you need, but we can expand it in this way. So with it being arithmetic, you can say term 2 minus term 1, what is it? Cos square x, right? Minus sine square x. Term 3 minus term 2, what is it? Sine x cos x minus cos squared x, right? Minus cos squared x. So because they said this is arithmetic, is an arithmetic sequence, we know that the difference, the first difference is common. What does that mean? That means cos square x minus sine square x is the same or is equal to sine x cos x minus cos square x. Okay, the way that I wrote this on the screen, you can also write it in your answer book. Okay, good. Now let's go. Proceeding, you collect like terms. I will move everything to the right. This step is not necessary. Okay, I'm just writing it for you to just follow. Okay, but it's really not necessary. Okay, plus cos square x equals 0. So collecting like terms, we have 2 cos square x's. So this becomes 2 cos square x. The middle term will be minus sine x cos x, and the outer term will be minus sine square x, and all these equal 0. All right, and all these equal 0. It seems here we can factorize this. So our factorization will be 2 cos x minus, definitely minus sine x, close bracket open, cos x minus sine x close equals 0. The reason I wrote minus for all of them is because it's easy to make it a positive. So the bigger factor, since the constant, which is the minus sine square x, or since the sine square x is negative, the bigger factor must take the middle of the must take the sign of the middle term. The middle term is negative. So this one must be negative. So this will be positive. Okay? So this is me now explaining to you guys. Proceeding, we will say this then becomes, let me see, sine x equals negative 2 cos x, or negative sine x equals negative cos x. Dividing throughout by cos x. Let me show you. It's like I'm just doing this. I'm doing the same even here. Here I'm going to be dividing by negative cos x. Okay? I'm going to be dividing by negative cos x. So I'm basically trying to say tan x over cos x is tan x. Then negative 2 cos x divided by cos x, we are left with negative 2. Negative sine x over negative cos x will become tan x, and negative cos x divided by negative cos x is positive 1. Then we have to take each of these by parts. Because we don't have enough space, I will just begin with tan x equals negative 2. Okay, I'm underlining it. And then I'm going to rewrite it again. Tan x equals negative 2. Our reference angle will be tan inverse of positive 2, because we want to get an acute angle that is less than 90 degrees. Okay, taking out your calculators, this will give you 63.43. It's shift tan, or second function tan. It gives you 63.43, isn't it? 63.43 degrees. Cool. So as you can see, sorry, tangent is negative. So where is tangent negative? I'm writing the statement so you ace this. Tangent, it's not important. I'm just writing it to help you. Tangent is negative where? In the second and fourth quadrant. Right? In the second and fourth quadrant. Right? Now proceeding, in the second quadrant, our angle here is x. X equals the reduction formula of the second quadrant is 180 degrees minus your reference angle. Our reference angle is 60. Oops, I should have written second quadrant. Guys, even if you don't write it, it's okay, meh? Minus 63.43 degrees plus 360 degrees k, where k is an element of an integer. So this will become 180 minus 63.43. It will become 116,57, isn't it? 116, 5,57 degrees plus. Hold on. This one is tangent. It's not supposed to be 360, but 180. Okay, so please change it. It should be 180. So it's plus 180 degrees K. All right. We said tangent is also negative in the fourth quadrant. So let's look for the equation of the fourth quadrant. Let's look for it. So equation of the fourth quadrant. Let's do this. We will say x equals, in the fourth quadrant, we work with 360 minus the reference angle. So it's 360 degrees minus the reference angle, 63.43 degrees plus, we say 180 degrees K, because we're working with a tangent, isn't it? This was tan x, right? Where K is an element of an integer. All right. So what is x? 360 minus 63.43 will become 296.57 degrees plus 180 degrees K. We are done. Now, we also had tan x equals 1. Now we're looking at it. For tan x equals 1, we say, once again, tan x equals 1. Our reference angle is tan inverse of 1. This is 45 degrees, isn't it? Once again, you can see this is tan equals positive 1. So we know tan is positive in which quadrant? Tan is positive in the first and third quadrants. All right? Tan is positive in the first and fourth quadrants. So the third quadrant. So the first quadrant. So the first quadrant, we say x equals the reference angle S is, okay, will be 45 degrees plus 180 degrees K, where K is an element of an integer. We are done. Now let's go to the third quadrant. The third quadrant, we are going to say x equals, what is the reduction formula for the third quadrant? It's 180 minus the reference angle. No, it's 180 plus. Third quadrant is 180 plus. So it's going to be 180 plus. The reference angle here is 45 degrees plus 180 degrees K, where K is an element of an integer. Therefore, x is 180 plus 45 is 22. Yo, come on. It's not 22. 180 plus 45, right? 180 plus 45 is 225. Okay, it's 225. So this becomes 225 degrees plus 180 degrees K. We are done with question 6. We are now about 2-3 minutes behind, right? We are now about 2-3 minutes behind. Okay, so let's just go to the next question. The next question, I like this question. Okay, let's go. This is question, let me see. Okay, this is question 7. So let's see, question 7. So question 7, we are saying, let's see, in the diagram, the graph of f of x equals cos 2x is drawn for x is an element of negative 135 degrees included until positive 135 degrees included. Write down the period of f. You do not need to worry. For you to determine a period, you can just say, how many degrees does it take to complete a full wave? Right? This is half a wave. This is another half. So 2 halves make a wave. So you can say 135 minus negative 45, it will be 180. 7.1. The period is, we can simply say 180 degrees. Or we can just use the formula. Period equals, this is cosine, so you must say 360 degrees over b. This is what you know, right? This is what you know, isn't it? All right. Now you can say, okay, your period is 360 degrees over, what is b? B is the coefficient of x, which is 2. And this will give you 180 degrees. Okay. Moving on. 7.2. On the same set of x's provided in the answer book, draw the graph of g of x equals tan 2x. I want to say something about this. G of x is tan 2x minus 1. This says to you, when you plot this graph for tangent, for your scale, what you call on your calculator a step, it'll be 45 degrees divided by b. And this therefore means 45 degrees divided by b is the coefficient of x. It's divided by 2. This says on your calculator, your step must be 22,5. Now let me show you how you're going to plot this. But before that, let me just draw this graph. Okay, so let's say this is negative 135, and this is negative 90 degrees. This one here is negative 45 degrees. And then let me just make this to be 0. And then this will be positive 45 degrees, positive 90 degrees, and then positive 135 degrees. This is x. I'm going to make this one and make this one 2. And this is y. And the same way, 1, 2, negative, negative. Okay. So let's go now. Now, the graph that we have is that of g of x. It's like this. Okay. I'll just draw it nicely. Okay. It's like this. Okay. All right. So it is like this. This is our f of x, right? So our g of x, I'm going to show you what should display on your calculator. On your calculator, you go to mode. If you're using Casio, you go to mode. Those that are using Sharp, I think you also know. You go to mode, option 7. Then you say tan 2 alpha x, then close bracket, okay? And close bracket is very important. Close bracket minus 1. Okay, remember this inside the bracket, it cannot be this minus 1. It should be some number given as a degree, not just a number without a degree. Okay, proceeding. Then forget g of x. Then where do you start? You're starting at negative 135, enter. You end at positive 135, enter. I said your step is 22,5. Then enter. Let's start. Now, what do you see when your x is negative 135? There's an error that says it's an asymptote, right? When your x is negative 112, it's midway here, it's negative 2. When it's negative 90, it's 1. When it's, let's see, when it's negative 67, okay, 90, I've passed. Negative 67, 5 is 0, and then 45 is an asymptote. So it seems I'm getting asymptote every 90 degrees. So it seems I'm going to get another one at positive 45, another one at positive 135, right? So then our graph seems to be moving like this. Okay, it seems to be moving like that. So I'll just say this one here. I have already seen the behavior. Yep, bear with me, guys. I've already seen the behavior. So it'll be moving like this. Okay, it'll be moving like this. But let's confirm. Indeed, at x equals 0, it is -1 correct. At x equals 22,5 it's 0. That's correct. 45 error. 67,5 -2. Aha. So this is it. Do you guys see this? So this is it. We are fine. Let's move on. So this is our 3 marks. Moving on. This is our F. Right. They didn't have any specifics. Okay. 7.3. Let's see. 7.3, f of x is graph f is translated 45 degrees to the left to form h. So this means, what does it mean for us? It means 7.3. 7.3 means, oh boy, come on. So 7.3 means h of x is basically f of x translated 45 degrees to the left. So to shift to the left, you will have to add a 45 degrees to the x. And therefore, this says on f of x, wherever there's x, you're going to put x plus 45 degrees. Remember, shifting to the left will be a positive value. So let's go now. This will become cos 2 times x is 2x. 2 times 45 is 90 degrees. You know this as cos 90 degrees plus 2x. Do you see this? 90 degrees is positive, 2x is positive. It's a matter of swapping the values around, not to change how they look. Okay? Perfect. Let's move on now. This therefore says cos in the 90 plus quadrant, is it positive or negative? It's negative. But because of the 90, cosine changes, it becomes the sine, and this will become negative sine 2x. That's your h of x. All right? Good. 7.4. 7.4 says, write down the range of h. H is your normal sine graph, but it's the one that's moving like this. Its coefficient is -1. So it means minimum is -1, maximum is 1. So the range you will say y is an element of -1 included to +1 included. As simple as that. Okay. So 7.5, let's go. 7.5, determine the value or values of x for which, open bracket, I want you to be careful with this one. 1 minus tan 2x close open cos 2x close is greater or equal to 0. You have never worked with 1 minus tan 2x. You have worked with tan 2x minus 1. So I advise take a common factor here of -1. It will be negative as a common factor. You can say you are left with tan 2x minus 1 close open cos 2x is greater or equal to 0. You have worked with tan 2x minus 1 and cos 2x. The cos 2x is the one that's drawn. Tan 2x minus 1, you draw it. Now, get rid of the negative. You divide by the negative throughout, and this will become tan 2x minus 1 close open cos 2x close. Because you divided by negative, it'll change direction. You go to your graph now. When you go to your graph, you say both of them, their product, or rather the product of these two graphs. Let me show you. This is g of x. So it's basically saying g of x times, is it f of x? The one that we had, oops. Come on, buddy. So it's f of x. G of x times f of x must be less or equal to 0. There's a video that I've done about these kind of questions, right? If I remember, I will try to pin it for you guys, okay? You might need to check the top right of your screen. You will see a message popping. If I don't add it, guys, please comment. Don't forget to add the link that explains relationships between graphs. Okay, let's move on. All right, so we are saying the product of these two must either be 0 or be negative. Let's go to our graphs. Remember, the product must be negative. It means if one is positive, if one is positive, sorry, if one is positive, the other must be negative. Okay. And another condition is that they must be equal to 0 at some point. So it is in the domain 0 degrees to 135 degrees. Let's go. I'm going to check this out. Okay. When one is positive, the other must be negative. For 0 degrees until, or from 0 degrees until 22,5, one is positive, the other is negative. That's what we are looking for. So I'm going to say this is when x is greater or equal to 0, but less or equal to 22,5. Or, let's see, or, let's go check it out. From 22,5 to 45, both are positive. We are not interested in that. 45 to 90, both are negative. We are not interested in that. From 90 to, I believe this one will be, what will it be? I think it will be 1 something, 112,5, right? 90 plus 22,5 will be 112,5, right? So let me repeat. From 90 to 112,5, both are negative. We are not interested in that. From 112,5 until 135, one is positive, the other is negative. And be careful, one does not exist at 135. So it must be x is greater than, so x is greater than 112,5, no, x is greater or equal to 112,5, but less than 135. I'm saying less than 135 because your g of x does not exist at 135. Okay, hence I'm saying less. I'm not saying less or equal to. And this is us. Do you see? We have now had 10 extra minutes. Do you see this? We now have about 10 extra minutes. Is it 10? Yeah, 8, maybe 7. Now let's go to the last question. So the last question, let's see. Question 8. So let's see question 8. So much reading. Do I need, let me try to zoom this in a bit. 85, let me check 85. Yeah, it's fine. All right. All right. As part of a school project, learners are required to design a portable stage for a puppet show, as shown in the diagram below. The design must fulfill the following requirements. BKLC is a horizontal base. Where is it? Okay, see it. It's a horizontal base having angle BKC equals 104, and then angle KBC equals 104, and angle BKC equals 52,6. I see them. The rectangular backdrop ABCD, I see it, is vertical to the horizontal base and must have an area of 648 square meters. I see it. The sides of ABCD must be, did you hear this? The sides of ABCD must be the ratio AB is to BC is equal to 1 is to 2. What does that mean, guys? That means BC is twice the size of AB. This is what the ratio means. The stage must be partly enclosed with rectangular sides ABK and DCL. 8.1, let's go now. 8.1 says, show that AB is equal to 18 centimeters. So hold on, I will say to you, AB over BC is equal to 1 over 2. It's the same thing, guys. Cross multiply, multiply followed by BC, and multiply throughout by 2. Maybe for those that will struggle, I want to say this to you. This is basically saying 2 times AB is equal to BC. I will explain. This is to say AB will be equal to half times BC. Then multiplying throughout by 2, it'll take you here. Okay? Perfect. Now let's answer the question. ABCD is a rectangle. So area of ABCD is what? Is area, rather is side AB times side BC, right? So this is 648. And then we said AB is, okay, leave AB as is. We said BC is twice AB, right? So this says 648 equals 2 times AB squared. Now 648 divided by 2. Okay, divided by 2, what do you get? When you divide 648 by 2, you get 324. This equals AB squared. Now the square root of this guy is 18, right? Therefore, you say 8B is 18. For those that may be wondering, we just said AB equals the square root of 324, and then it brought you here. Okay? So we are good. Don't forget to add centimeters because it's your final answer. 8.2, calculate the length of AC. Where is AC? Good thing, you know what AB is, you know what BC is. And then you are told to find AC. We'll use Pythagoras, okay? So I will say, this is me. I will say, using Pythagoras theorem, easy peasy. I will say AC squared equals AB squared plus BC squared, okay? So AC squared is, what is AB? AB, maybe let me do this. AB squared plus 2 times 2 times AB squared. So what is this? This says to you AC squared is AB squared plus 2 times AB squared. It's the same as saying x plus 2x. So this will give you 3AB squared. Okay. Now let's go. AC squared equals 3 times 18 squared. I know, guys, this looks long, but remember, this video is not only for A students, it's for everyone. So you guys ace your exams, right? So this is 972. Now you say AC squared, AC equals, if you like, square root of your 972. It'll give you 18 root 3. Once again, this means I just said this, okay? And then it gives me this, okay? All right. So this, if you like, you can leave it here, but because it's your final answer, you can say AC is 31.18 centimeters. Okay? Is it so? I'm not sure, guys. I'm really not sure. Oh, and there's a mistake we made. A terrible mistake. Shall we fix it? Let's fix that mistake. There's a mistake, a terrible one. Okay, there's a terrible mistake we made. And that mistake, guys, we need to fix it. This is supposed to be inside a square root. Okay, it's supposed to be inside a square root. Okay, hence, I don't like making such mistakes. I want to make sure that we are on the right track. This AB squared is fine. This is 2 squared. 2 squared will be 4, and then 4 times AB squared. So further, we will say this is 5AB squared. Then we can say AC squared equals 518 squared. And we know, let's see, 5 times 18 squared will be 1620. Once again, this, or rather, finally, square root of this guy will be 18 root 5. I will repeat it again. I will say this is because we said AC equals square root of 1620. Okay? Okay. All right. Perfect. Now, moving on. Okay, now moving on. If you like, by the way, you should write this as a decimal. So we can then say, therefore, AC is 40,25 centimeters. Okay, 18,25 centimeters. All right. Now, we then go to 8.3. 8.3 says, calculate the length of diagonal KC. Diagonal KC, where is it? It is this one here. So note, you basically know what BC is, right? And then you are required to find KC. So KC is a side that is opposite angle KBC. So you also know BC, and BC is a side that is opposite angle BKC. These angles are given. So being given two sides or a side and its included angle, and then given another angle but required to find its opposite side, use sine rule. So your sine rule says, by the way, the formula is also given. Sine rule says A over sine A equals B over sine B in whatever form. Even if it's sine A over small a equals sine B over small b, it's the same thing. Okay. So this is the formula that you need. Okay. Now let's go. So we will say, for example, we need a KC. We will say KC over sine angle KC is opposite sine angle KBC. And then we have BC. BC is opposite the angle BKC, right? Angle BKC, right? There's something that we know about BC, right? So let me just do this. BC, we know it's twice. I'll just write it here. BC is twice AB, right? BC is twice AB, so we are good to go. Let's substitute. KC is unknown. Sine KBC is 104 degrees. And this guy is basically 2 times 18. And then BKC is 52,6. Right? All right. So what you can do here is multiply throughout by sine 104. So basically, you're having something like this. 2 times 18 over sine 52,6 degrees multiplied by sine 104 degrees. Press this on your calculator. You are good to go. Okay. Okay. So what is this giving us? 6 over 36 over sine 52,6. All multiplied by sine 104. What do we have? So we got, let's see, we got 43,97 degrees. Right. We got 43,97 degrees. Right. Now let's go to 8.4. 8.4. Yeah. Oh, sorry. KC, guys, is not in degrees, is in centimeters. My mistake. Thank you. Now, 8.4. If AB equals BK, I hope you guys are hearing this. If AB equals BK, calculate the sine of KAC. Right? So the sine of KAC, wow. The size of angle KAC. So we already know KC, and we are told, we also know AC. We may need to find AK. Okay. So I will say, this is me now for 4 marks. Or maybe let's just do this. Do we have any information given that may simplify this? The size of angle KAC. Nah, we will need to do this. In triangle ABK. Okay, in triangle ABK, I will say this. AK, it seems to be a hypotenuse. All right, so I will say AK, okay, AK squared equals AB squared plus what? Plus BK squared, right? And they said to us, AB equals BK. So we can just say this, AB squared plus AB squared, because BK equals this. BK equals AB, right? Cool. So this says we have 2 times AB squared. Right. Moving on. This is AK squared, okay? So we then say, hold on. Knowing this, we can then say, okay, AK squared equals 2 times 18 squared. Or, you know what, let's save time. Nah, but it's fine. All right. Now, AK squared equals 2 times 18 squared. This is 648. It's fine. 648. Now, the square root of 648 is, I'm going to leave it as 18 root 2 for now. Okay. I'm going to leave it as 18 root 2 for now. Okay. Now, then we go to in triangle ACK. Okay. Did I say ACK? Yeah. In triangle ACK. In triangle ACK. It's this one here. Okay. In triangle ACK. All right. Now let's go. Here we will use cosine rule. Okay. Here we will use cosine rule, and our usage of cosine rule is this. We do not know. Maybe let me show you. Okay, so this is A, this is C, this is K. This one we know, right? And then this one, KC. Yes, we also we also know KC, and we just found this one here. They want us to find this one. So definitely we are using cosine rule. Okay, definitely we are using cosine rule. So let's go. We'll then say, let's see. We'll then say, let me see, cosine rule. We will say KC. Okay, so we'll say KC squared equals AC squared plus AK squared minus 2 times AC times AK times cos angle KAC. All right, times angle KAC. What is KC? We did find KC, 47,97 centimeters. Right? 47 or 43? 43,97, right? 43,97 square. What is AC? Hold on. Did we find AC? Yes, we did. What was it? It was 40,25. I'll take those values. 40,25 square plus, what is AK? I'm just going to write it as 18 root 2 as is, minus 2 times 40,25 18 root 2 times cos angle KAC. All right, let's go now. 43,97 squared will be 43,97 squared will be 1933,3609, right? 3609. 40,25 squared will be 1620,0625 square, open bracket 18 root 2 and then close bracket square will be 648, right? This is 648. Okay, perfect. Minus 2 times 40,25 times 18 root 2 times 18 root 2, all right, will be, this one will be 2049, 1950, okay, 1954.52 cos angle KAC. All right, let's go. Now, let's take this one to the left. So we'll take this 2049,1954.52 cos angle KAC will be equal to 1620,0625 plus 648. The 1933,3609 is positive. When it comes to the right, it will be negative. Minus 1953,3609. Now, let's get this part. Okay. 1620,0625 plus 648 minus. What do we get? So let's sort this out. So 2049,1954.52 cos angle KAC is equal to 334,7016. So taking it step by step, bear with me. Cos KAC equals 334,7016 divided by 2049,1954.52. Then it says this guy here is equal to 0.1633331753. Then cos angle KAC will be cos angle KAC is equal to cos inverse of 0.1633. Guys, even if you write 3 decimal places, it's okay. Not 3, 4 to 5 decimal places would do. All right. So let's see. Cos inverse of, in my calculator, I'm going to say inverse of answer. Therefore, KAC is equal to 80,60 seconds. Okay, KAC is 80,60 seconds. Guys, do you see how long this question was? And that's why you have to make sure that you use your time wisely. Okay, but this is because I'm explaining. In the exam, you won't be explaining. Right? With that being said, it's a wrap and bye-bye.